Welcome to the Climate Program Office NOFO FY23 Earth System Science and Modeling Research for Coastal Inundation Funding Opportunity informational webinar. I'm Ginny Sells. I'm the Program Manager for the Climate Variability and Predictability Program. And we'll start with a round of introductions. So Dan, could you go next?
Yeah, thanks, Ginny. Hi, everyone. I'm Dan Barry. I manage the Modeling Analysis Predictions and Projections Program in CPO.
And can we hear from GFDL?
I'm Stephen Griffiths, work at GFDL doing ocean modeling, sea level work related, as well as lots of other things.
Hi, my name is John Crasting. I'm a physical scientist here also at GFDL. Work on the ocean's role in climate and work on sea level and ocean heat and carbon uptake. I coordinate many of our sea level activities across the lab.
And National Ocean Service?
Hi, everyone. William Sweet. I work for the National Ocean Service. My main role is to help improve the science, but more importantly, the services associated around sea level rise and what does that mean for coastal flooding risk in communities across the country.
Thanks. And with that, we'll start with our presentations. All right. So we just did our welcome and introductions. I'll go over the NOFO scope and motivation, and then we'll hear from our OAR and NOS colleagues. Billy Sweet is here to answer questions specifically regarding NOS, and John Christine will talk about work going on throughout the agency. We'll also then move on to the NOFO details, process, and frequently asked questions, and then wrap up. So we are here to talk about the Notice of Funding Opportunity titled Climate Program Office, Earth System Science and Modeling Research for Coastal Inundation. If this is what you're interested in, you are in the right place. This NOFO is very relevant to NOAA's mission, which is science, service, and stewardship. These are the three pillars supporting the agency's leadership and understanding and predicting changes in climate, weather, oceans, and coasts, and getting actionable environmental information into the hands of decision makers. This Notice of Funding Opportunity is funded through the Infrastructure Investment and Jobs Act, or the bipartisan BIL, the Bipartisan Infrastructure Law, NOAA Section Provision 3, Coastal and Inland Flood and Inundation Mapping and Forecasting. And this is very aligned with NOAA's Coastal Flooding and Inundation Information and Services Strategy. This strategy is publicly available. There's a link to it in the NOFO, and we invite you to review that strategy as you develop your letters of intent. The NOFO focuses on improving the understanding and modeling of coupled ocean, climate, land, hydrologic, hydrodynamic, wave drivers, and contributions to mean and extreme total water levels. And here we're focused on key processes that are most important to the seasonal to annual timescale. So what we hope to gain out of the NOFO and out of funded projects is anticipated outcomes. And so we hope that the projects result in information that can inform the development of future versions of coastal inundation observations and projection systems on a national level. And so those systems ideally would deliver a comprehensive suite of predictions over various timescales with high fidelity. And so there are many details in the NOFO, but we've pulled out and emphasized these here. So here we're emphasizing collaborations with NOAA. And the NOFO specifies that NOAA collaborators may receive up to 20% of the total budget. We're emphasizing the use of NOAA observational data and or coupled models, and those include, but are not limited to, SPEAR, SHIELD, UFS, MOM6, ROMS, and other prominent multi-model prediction systems like NMME and SubX. Projects may perform this research in the context of or using platforms of current or potential operational relevance, which we will hear more about today. And projects that CPO typically funds fall in or near readiness levels 1 or 2. And you can read more about NOAA's technical readiness levels on their website. The 2 CPO programs that are supporting the SNOFO and coordinating the SNOFO are the Climate Variability and Predictability Program, which I manage, and the Modeling, Analysis, Predictions, and Projections Program, which Dan Barry manages. And these 2 programs combined support research that enhances our process level understanding of the climate system and supports advances in the development and application of Earth system models and analyses across NOAA. And in your NOFOs, you do not need, or in your letters of intent, you do not need to specify which program you are applying to. There's only one competition, and CVP and MAPP are working together to move the goals for coastal inundation forward. So if you have questions that you do not want to ask today, you can email both myself and Dan Barry. Please email us both. But we can take questions on the NOFO scope and motivation at this time.
So go ahead and please use the questions feature on the go-to panel to enter questions that you have about the funding opportunity, or you can raise your hand to be unmuted to ask your question directly.
I think we'll give it about a minute for questions. And if there are no questions, we can move on to the discussion with GFDL and NOS.
Okay, we've got one question that came in. Can I participate in more than one proposal?
Yes, you are not limited in terms of number of proposals you can participate in.
Great. Another question. Are there any limits on the time scales of interest for the NOFO?
As we mentioned, the processes that the NOFO emphasizes is the seasonal to annual timescale. Processes most important to the seasonal to annual timescale.
Okay, one more question. Does the proposal have to focus on coastal regions, or will proposals focused on other regions also be considered?
So Dan, correct me if I'm wrong, but the proposal should focus on improving predictions, observational systems or predictions at the coastal scale. And so if the proposal focuses on other regions besides the coast, it should articulate how that then improves the prediction or observation systems, how the outcomes of the proposal will improve the predictions or observation systems at the coastal scale.
Yeah, I'd agree with that. I guess maybe the question is like Great Lakes issues. I think we're really focused on the coastline, the maritime coastline, but maybe that's something that Billy could comment on from an NOS perspective, especially when he presents.
Okay, great. Another question is there a page limit for the LOI?
So we're going to get into process detail type NOFO questions towards the end of the call. I can just go ahead and say there's a 2-page limit on LOIs, but I'd ask you hold those towards the end of the call.
Great. Another question, are there limitations on funding of other federal agencies?
So we've funded other federal agencies in the past, and I think that's something that we could talk about on a case-by-case basis during the LOI process.
Sounds good. That wraps up all the questions that we have at the moment. Oh, sorry, one more. Regarding recommended SPEAR product, does all variables needed for downscaling, like 3D, temperature, salinity, U and V velocities, or will that be made available?
I would probably ask John and Steve to take a first crack at that. If they can't or don't want to answer that, I could provide an answer. But do you want to comment on that, John?
And certainly. Really, that is a question for the SPEAR development team. The leadership of that is Tom Delworth. But from previous calls through CPO that have involved the SPEAR output, there is a publicly available site that's hosted by GFDL that has cataloging of all of the data that we've made available thus far.
Yeah, so what I would add to that, just because I have some recent experience with our projection solicitation, is that I think of the variables Jason listed, salinity is not available, and there is limited 3D data available. What I would say is that you should plan your project around the variables that are available through the database John mentioned. There is the possibility during the project that other variables could potentially be made available, but that would probably be a conversation for after the project is funded, where we would reach out and talk about that. And I would recommend not reaching out to the SPEAR team at the moment, unless you have a pre-existing relationship with them, because they're not really set up to answer or support these kind of questions at the moment.
Great, thank you. I think we are clear to move forward.
Yep, so with that, I'll invite John Christine to present.
Okay, thanks, Jenny. So the objective here today is for me to give you a flavor of some of the activities that we're doing within OAR, the Oceanic and Atmospheric Research Line Office within NOAA, that are related to sea level. So with me today is also Stephen Griffiths at GFDL, and Matt Newman is currently attending the AMS conference out in Colorado, but has contributed some material to the presentation I'm going to give you today. I'd like to thank also Bob Hallberg and Brung Zhang at GFDL for some additional input on these slides. And this is, again, meant to be a flavor of what we have. It's not all encompassing of everything at OAR. So I do encourage you also to seek out materials that are on other OAR lab websites for more information on what we're doing related to sea level. Next slide, please. So again, sort of the importance of why sea level rise and modeling and projections is relevant to what we do in OAR. This ties to our strategic plan and maps into aspects of, and we can bring these up, climate adaptation and mitigation. So informing society about sea level rise and giving opportunities for us to address impacts, building resilient coastal communities and economies, which again have an important impact on our economy. And then finally, our stewardship element of healthy oceans and preserving coastal ecosystems, which are vital to our economy and recreation. Next slide. So I want to call your attention to a recent event that just happened a couple of weeks ago here in the Northeast, the December 2022 flooding event, which where New Jersey and New York City saw the highest water levels since Superstorm Sandy. I want to point out that from some perspectives, this has been a great success. The early indications of this being an important event for this region were highlighted in the high tide bulletins that the NOS puts out weeks in advance. And the National Weather Service forecast offices had timely products and warnings out for coastal flooding. And here in this region, we have the benefit of modeling efforts from the Stevens Institute of Technologies and their forecast system, which, based on NOAA products, significantly and appropriately forecasted this event well in advance. Now, despite all of the advance warning that we had on the significance of this event, the news reports here in the New York City and Philadelphia region were dominated by the element of surprise. And many folks, particularly in the Far Rockaways, seen here on the right, and in northern New Jersey, were caught off guard by the magnitude of this event. So clearly, we have a lot of work to do in terms of predicting and communicating the effects of these high tide events and coastal inundation. Just some perspective, the New York City, Philadelphia combined statistical region is home to 26 million people. 6 of the 7 most expensive zip codes for housing in the Philadelphia region are coastal communities along the Jersey Shore, highlighting the economic impacts that we have. The recent studies by Rutgers University project that the frequency of sunny day flooding events by 2050, the magnitude will exceed the current 10-year flood event, which is currently at 3.3 feet. And under a moderate warming scenario, floods like Sandy, which are a 5-foot surge, could occur on a yearly basis. And just for magnitude, the surge here in this event that we saw in Sandy Hook was about 3 feet. So next slide. Sea level rise is linked to Earth system processes. As we know, sea level is an integrator of many different processes throughout the Earth system. But it's important to note that no collection of models or observations or individual models and observations can simulate the whole processes that are involved in sea level. We really need an integrated approach across the modeling and observational enterprise to understand this. Some of the processes that are included in GFDL's models include thermal expansion, ocean circulation, hydrologic processes, but notable ones that are important from a practical perspective that are not yet in GFDL's global models include the glacier and ice mass balance and the effects of changes to the geoid. If we look at progress over the last decade, one of the most important advances that we've seen is significant work towards closing the sea level budget and understanding how the observed changes in sea level rise can be attributed to different drivers. And our ability to model the Earth system has played an important role in reducing the uncertainty in a number of these terms. Next slide. The global mean sea level rise has been featured in the last IPCC report, AR6. Updates this go around. Thermal expansion is accounting for about 50% of the sea level rise that's been observed since 1971. There's still considerable uncertainty that remains in the projections going out to the end of the century. A lot of this uncertainty stems from the forcing pathway, so that uncertainty over what trajectory anthropogenic climate change might take over the coming decades. But the most likely global sea level projections are anywhere from about 1/4 to 1 meter of sea level rise relative to late 20th century levels. And it's important to note that these ranges do not include models that simulate marine ice cliff instability or other effects of land ice melt that could lead to more extreme scenarios. The AR6 updated projections are modestly higher than those we saw in AR5. And again, most of the contributing factors are consistent going from AR5 to AR6, except for this Antarctic ice melt piece. Next slide. So OAR's model development activities, and in particular GFDL, seek to address the following questions. So how well do our dynamical models perform at simulating sea level? Why do the models perform the way they do? And then what can we improve in the models going forward to reduce our uncertainty in predictions and projections? Next slide. GFDL's fourth generation model hierarchy is shown here. These are the coupled models that have formed the backbone of our contributions to projects such as the Coupled Model Intercomparison Project and underpinning of AR6. On the left, we have the GFDL CM4 model. This is a order 1 kilometer atmosphere, quarter degree resolution ocean, which we call eddy permitting. This includes the MAPP model as its basis, and we have updated versions of the sea ice and land configurations. In the middle, we have our Earth system model, which has increased complexity in terms of atmospheric chemistry and biogeochemistry and land ecology. But in order to keep it computationally on par with CM4, this model features a slightly reduced horizontal resolution in the ocean, so a half-degree resolution, and it does rely on a mesoscale eddy parameterization. And then finally, on the right, we have the model that we use for seasonal prediction, the SPEAR model. And this model features 2 different versions on the atmosphere, what we call a low resolution, which is also 1 degree, and then a medium resolution or a half-degree atmosphere. And in both cases, this model is coupled to a 1 degree ocean, with the prioritization again being on the atmospheric resolution in order to tailor that to the use case of seasonal prediction. Next slide. We have a number of modeling efforts which are currently under development at GFDL, but are also relevant for the sea level coastal inundation problem. We are developing a series of regional ocean models with very high resolution 3 kilometer domains along the US coastline. These include the Northwest Atlantic, the Pacific, and the Gulf of Alaska domains. We have a high resolution global modeling effort underway. This is taking the CM4 base configuration, but upgrading the resolutions of both the ocean and the atmosphere. And also we're doing long-term research on developing coupled ice sheet models that can be brought into the coupled system so that we can understand the interactions of land ice processes and how they feed back to the ocean. All of this is feeding into a pipeline of an attempt to develop process-oriented diagnostics and evaluate our models, again, answering the how and why questions that I mentioned earlier about what processes are performing well in our models and why sea level is evolving the way it does in our models. And of course, a lot of this relies on leveraging observations in order to do this well. Next slide. So 3 areas of GFDL sea level research over the last 15 years has really focused on 3 main themes. The first is this foundational model analysis and development activity. So building the models that we're using in these predictions and projection efforts. The second is the process-based understanding. So understanding what it is about the ocean physical and dynamical system across a variety of different spatial and time scales to understand the drivers of sea level. And then finally, understanding the impacts. So how do we expect sea level to change on different time scales going forward? And what are the interactions with things such as carbon emissions and increased storm activity and hurricanes, for example. Next slide. So our key research themes for model development as they relate to sea level rise, what is the impact of resolution on process representation and skill? So as you see, we have a hierarchy of models that span a nice range of different atmospheric and ocean resolutions to get at this question. We are looking at the sea level variability across different timescales. So as we move towards what's called seamless prediction across different timescales, we're trying to assess both the long-term climate evolution as well as the short-term variability in order to use the same set of models and principles towards an integrative approach across timescales. And all this involves understanding how the ocean physical and dynamical drivers of sea level will operate in our models and change in the future, and also studying the coupled Earth system impacts of how changes in sea level may feed back to other aspects of the Earth system, such as biogeochemistry and coastal ecosystems. Next slide. There are a couple of sea level initiatives and funding efforts that involve OAR. Ginny mentioned these in the introduction. They are also operating within OAR at the programmatic level. So again, this bipartisan infrastructure law has additional elements that are funding the study and improvement of processes in regional MOM6, and also exploring subseasonal to annual predictability using statistical and dynamical modeling, again, using the SPEAR model. A lot of this is complementary to the things that will be funded through this NOFO. And on the right, we have the Coastal Inundation and Climate Timescales Initiative. A lot of this is encompassed and wrapped up in this Coastal Inundation and Climate Timescales white paper, which Jenny mentioned. I would encourage you to read that to see more of the strategy of what we are doing with our dedicated line funding, in addition to some of the competitive grants that are being offered through NOAA. Next slide. So transitioning more now to the applications of what we're doing with some of the model output, a couple of vignettes, and a lot of this work is courtesy of Matt Newman. So one is the RISE effort. This is an effort to develop the next generation of sea level prediction systems across timescales. This is a 5-year timescale effort that we're doing in partnership with NOAA and NASA to work on a series of observational modeling and statistical dynamical downscaling efforts to transition something ideally to operations that can be used for seasonal forecasting of sea level extremes. So on the left here, what we're looking at is the performance of some of our raw dynamical models, along with dynamically downscaled projections using an echo-based adjoint model. One of the encouraging things here that we see is the root mean square error for the SPEAR model in light blue, along with the echo-based adjoints show a very significant improvement relative to climatology, at least on the half-year to seasonal timescales here relative to climatology, which is the gray line. The RISE effort is focusing primarily on 2 key locations, one on the West Coast, San Diego, and one on the East Coast in Charleston, South Carolina. Next slide. This slide highlights the need for a diverse set of tools when tackling the seasonal forecasting problem. On the right, what we're looking at is ROC scores, or reliability scores. And essentially these, if you're not familiar with them, relate the hit rate of a forecast, so how successful is that on the y-axis, compared to the false alarm rate, or how many times does a forecasted anomaly get predicted but doesn't occur. And ideally, you would want a model that has more hits than false alarms. And thus, you'll see that for many of these products here, the curves are a bit tilted to the upper left quadrant of the 1-to-1 line, which means hit rates equal false alarms. So essentially, the skill of the model you can think of as an integrated area underneath these curves between the colored lines and the gray line. So what we're looking at is terciles, above normal terciles, events neutral, which is in the middle, and then the lower third in blue. And on the left, we have a linear inverse model, or a sort of, you could think of as statistical machine learning based system trained on predicting anomalies. In the middle, we have the raw SPEAR output. And on the right, we have statistically downscaled SPEAR output. And the take-home message from this slide is that there's no clear winner in terms of the forecast skill. So for example, at San Diego, you can see the LIM performs modestly well, but is outperformed both by the dynamical model and the downscaled output of that model. Whereas it's more complicated in Charleston. The LIM seems to do fairly well, but we see reduced performance going to the dynamical sphere model and of course the dynamically or statistically corrected sphere output. So we need a diverse tool set in order to really address the seasonal prediction problem. So this is work by Matt Newman and Jiayu Long that's currently under preparation. Next slide. A lot of this work that is being done in relation to RISE is being made available through the RISE forecast website being hosted by PSL. So here you can find near real-time forecasts from not only SPEAR, but other NMME models that are participating in this effort. And you can also go back through the historical hindcasts that have been performed with these models and compare them against reanalysis and observations to assess their performance. Next slide. On the application side, from a climate perspective, we're also doing work with the National Ocean Service and Bob Kopp at Rutgers to look at how we can improve our climate scale projections of sea level and how they feed into frameworks, probabilistic frameworks that then provide the basis for sea level rise scenarios that are used throughout the federal government. A lot of this is detailed in the recently released report by Billy Sweet, lead author, leading a multi-agency team, this interagency sea level task force, to update these sea level rise projections, which are used throughout the federal government that go out to 2100. Next slide. And finally, as a transition into some of the things that Billy will talk about next, this 2022 Interagency Sea Level Rise Report, really has a lot of key messages. Over the next 30 years, we're expecting sea level to rise along the U.S. East Coast 10 to 12 inches. This is about the same as what we saw over the previous 100 years. We're expecting more flooding. Moderate events will occur at about 10 times more frequently than they do today. We see the linkages between carbon emissions. If we are to curb greenhouse gas emissions now, this report concludes that we could prevent up to 5 feet of additional sea level rise by 2100. And it also underscores the importance of continual tracking and why we need sustained observations and monitoring, which are crucial for adaptation and planning. So throughout all these key results, we can see that OAR's contributions through the modeling efforts and the applications of those models are a critical part, not only on the short-term prediction piece of this and extremes on weather to seasonal timescales, but also how those can cascade up, and we can see the overall evolution of climate change and how the sea level impacts may change in a warmer world. So that is a flavor for what we have at OAR. Guess, I don't know, Jenny, we're going to ask for questions now, or do we want to transition to Billy?
So we can open it up. First, I'll ask Billy if he has any additional remarks that he wants to add or ways he sees this effort contributing to the competition and potential projects contributing to the Provision 3 and BIL.
Sure. Well, I just have a few remarks, no slides prepared. As John mentioned, we have a strategy in the government, right, to provide scenarios of future sea level rise decades out. But we know the impacts are happening now from years of sea level rise, decades worth of sea level rise impacts already affecting our coast. High tide flooding, we're calling them, quite evident in the media in Miami, Charleston, Norfolk, Annapolis, Boston, New York, you name it. More and more communities are afflicted with sunny day flooding, no storm in sight. So it's not so much future scenarios, emission-based driving, future changes. It's really us now trying to predict the variability. On a year-to-year basis, sea level is still increasing, land still sinking. There is that signal, but the by and far the largest change will be variability in the system, whether it's affecting mean sea level or it's affecting the variability experienced during that season or that year, whether it's due to changes in storm track, storminess in general. You know, there's a combination of factors that cause flooding in the streets, and ultimately in terms of servicing the country, that's what we're ultimately after, is can we give guidance at a regional, local level of how many times do we think floodwaters, tidewaters will be spilling into communities, so that communities can be positioned, budgeting correctly to defend or respond to these types of flooding. And so as mentioned, there's several processes at play. We know the tides quite well. It's something that, you know, has been sort of dynamically solved over the last several decades. But what we don't really know is what is the changes in mean sea level and what's the variability piece. So if we think in this in terms of, for simplicity, a 2-parameter distribution of water levels in a given year or a given month, that distribution might shift due to changes in the mean, prolonged, sustained changes. But what's the variability? What's the width? The highs and lows, the storminess factor. You know, much of that isn't really tackled in the models that that John just explained. Statistically, there are ways that we can get at these solutions. So it's really going to be probably a combination of approaches that consider sea level rise, tide changes, the threshold as to which flooding occurs, storminess. You know, how do we capture these models? And what we can't capture in models, how can we statistically find ways of solving that part of the problem? So when we put it together, we come away with an improved ability to predict the variability piece that affects flooding in the streets, the number of days, the number of times that a community might be affected by flooding. That's the end goal, but this is feeding into the overall knowledge and know-how to get us there. So I think that's all I have to say on that.
Okay, thanks. And with that, we'll open it up to questions. And Clara, could you moderate for us again?
Yep, looks like we already have one question. Does NOAA produce any seasonal scale coastal inundation products to serve as benchmark? I don't believe CPC or NOS currently maintains such products.
So I would just, at this point, kick it back to Billy. I believe in this realm, the high tide bulletin, for example, is one example of things that are still put out on a seasonal timescale. But perhaps, Billy, you could comment more on the NOS's operational products.
Sure. Currently, our seasonal high tide bulletin really just identifies the days of the highest astronomical tide, which in many locations is the times when flooding will occur, meaning in areas with large tide ranges like the West Coast, Boston, even areas sometimes in the southern United States, Charleston. When it floods, oftentimes it's during these high astronomical tides. That's about where we are right now. We definitely are moving forward. There is a manuscript recently published, led by my colleague Greg Dusek, that sort of puts a framework into providing more likelihood on certain days of the calendar based upon climatological understanding of storminess, as well as mean sea level persistence, as well as sea level rise and the tide. So there's a sort of a framework that we're operating on. That will hopefully be introduced in the next year. But in terms of understanding skill, the best that we have currently is in our annual high tide flood outlook. We give annualized numbers, and in these reports, historically we've had 7 or 8 of them. We've in the last several of them have given an estimate of how many days were predicted and how many days actually occurred, looking back sort of in a hindsight retrospective view to give some sort of estimate as to, you know, how well are these annual outlooks doing within the range of days, flood days that are predicted. That's sort of where we are currently. So definitely some room for improvement still.
Great, we have another question. The collective impacts of nuisance flooding are much less than TC or ETCs, but there is not a paradigm for seasonal prediction of such events within NOAA as far as I can tell.
Was that a question or a comment?
Perhaps just a comment. If anyone else has some other questions, feel free to use the question feature in the panel on the go-to.
I think there is maybe a question in there about, maybe I'm trying to make a question out of a question. You know, is there a seasonal prediction of the impacts of nuisance flooding or the impacts of TCs or ETCs?
In terms of actual impacts, the way that we've been sort of addressing this thus far, not so much in tropical cyclone. We don't really have landfall predictions at a specific coastline. You know, typically that's the number of hurricanes predicted will be more of a basin with a certain amount making landfall. Very difficult to give that kind of predictive, you know, what will the impacts be. In terms of the sort of lesser extreme high tide floods, let's say that are more minor or moderate in severity, we are using impact thresholds that are calibrated to the National Weather Service that have implications on the ground. It's sort of hard to quantify exactly what the costs are, but for instance, minor flooding, when we have these thresholds and the elevations of which we can share, and we actually post on our website, there's a call to action, right? There are oftentimes certain streets that will be closed. There's a cost to commerce, to you know, to commutes, to patients. So it's a little bit more aligned with emergency manager responses. And that's sort of what we're targeting right now in terms of these seasonal annual outlooks. Is there's a cost to deploy people, police, pumps, personnel. There's a time, would be analogous to a particular snowy season in the Northeast. Are you positional? Do you have enough trucks and salt and people on the payroll to address what's likely to come? And we see that with sea level rise, the number of days of flooding causing streets to close, causing police to be out, is on the rise, and there's communities whose expenditures are going up. So is there hard, fast numbers? No, but is there association with a response that really has boots on the ground implications? Yes.
I would just follow up on that too, that you know, the way this question or comment's worded is it seems to portray a dichotomy, you know, that they're two classes, but it's really a continuum. And I think one of the things that lies in the middle, somewhere between nuisance flooding and say storm surge associated with a hurricane, or you know, the synoptic scale weather events that persist for several days, weeks at a time, blocking events, persistent onshore flow regimes. And I think that this is a potential area where we are trying to use seasonal prediction systems, NMME, statistical corrections to try to get at this element of it. When we look to the event that just happened along the Northeast coast last month, you know, this was, we saw flooding in the New York City region that was not seen in about 10 years, that came from a scenario where we had persistent onshore flow for 4 or 5 days and a storm system that was located several hundred miles to our west. This is, again, a very large magnitude event that was not associated with an event right on the coast. And I think there's some hope that by understanding connections with larger modes of climate variability and drivers, you know, ENSO, NAO, things of that sort, that we might be able to flesh out that middle part as well, which could be quite impactful.
Thank you. We have another question. Is there a preference for any specific coastal areas or specific model resolutions in addition to the seasonal annual timescale?
Well, I'll start, say decisions typically are made locally So, you know, it depends. Obviously, predictions of mean sea level will tend to have longer wavelengths to them, spatial wavelengths. A combined prediction looking at exceedances above some threshold that would take in other processes would likely be much more locally specific due to the hydrodynamics of a region. So I guess it's as good as you can get. And John, I don't know if you have more to add to that.
I think the only thing I would add is that, you know, recent research and literature has shown a predictability gap. You know, the Western United States tends to do a little bit better than the East Coast. You know, it's a complicated area. I think if I were to say from a modeling perspective, where we could use some additional insight is to, you know, what's really driving the variability, especially in the complexity of the East Coast basin.
And I guess I would add to that, that's a good point. You know, West Coast infill footprint has typically better predictability, though one would argue, anecdotally, you can see it in the media, that the Eastern Gulf Coast is more afflicted by what we would call sort of high tide flooding, just flat, low-lying flooding that's backing up these stormwater drains. Partially that's due to, you know, the configuration in the United States, shallow, wide continental shelves, water sets up much higher, sea level rise rates have been higher. Flooding's more of an issue. Communities are spending really money because they're flooding often. Sunny day flooding is an issue. So not to say it's not a growing concern on the West Coast where waves and erosion, bluff collapse, overwash, you know, the kind of things that we're witnessing today. But right now, I would say the high tide flood issue is more of a East and Gulf Coast region where the model skills are less than, let's say, the West Coast.
Great, thank you. It looks like we don't have any other questions in the question box at this time.
And again, if you have additional questions that you weren't able to ask on this webinar, please email them to Dan and I, and we will try to find the appropriate person to answer them if we cannot answer them for you. All right, so now on the agenda, we're moving on to the NOFO details and process. And so here I've highlighted important dates. Letters of intent should be received by email by 5 p.m. Eastern Time on January 27th, 2023. Full applications must be received by 5 p.m. Eastern Time, March 17th, 2023, and that's through grants.gov. Multi-institution proposals should submit separate but identical proposals. And so our office and our programs strongly discourage subawards and contracts. If you have questions about this, again, please email us both. Again, emphasizing that collaborations with federal investigators, especially NOAA investigators, are encouraged, and lead PIs can budget up to, but not more than 20% of the proposed budget. And there are details that explain this in the NOFO. And here we are requiring that if you do have a NOAA collaborator, you must include a letter of support acknowledging their participation in the proposed project. CPO follows a two-stage peer review process. Again, this is described in detail in the notice of funding opportunity if you would like to read further. Stage 1 equals 75% of the score, and that stage 1 panel evaluates the proposals on scientific technical merit, qualifications of the team, and appropriateness of the budget. And then proposals that score above a certain threshold move on to a stage 2 review panel, and that review panel is 25% of the score and evaluates the relevance of the proposal to the program and to NOAA. There were questions about the letter of intent process. Again, this is detailed in the NOFO. You are strongly encouraged to submit a letter of intent. It is not required, But the purpose of this process is for the program managers to provide you, the applicant, feedback on the relevance of your proposed project to the competition. And this is to save everyone time. You don't want your proposal to score very highly in the stage 1 panel and then get to the stage 2 panel and find out that it is not at all relevant. You could have found that information out during the LOI process in most cases. Elements of an LOI include, again, it's no more than 2 pages in length. It should identify the competition being targeted. In this case, there's only one competition. Include a title, names and institutions of the PIs, statement of the problem, summary of the work, approximate cost of the project, and importantly, relevance to the competition being targeted, because again, that is how the LOI is being reviewed by the program managers. So once the programs look through and review the LOIs, the applicants receive 3 kinds of responses. One is encouraged. The LOI addressed required elements of the call. 2 is marginally encouraged. It hit some, but not all required elements. And then 3 is discouraged. It does not address required elements. And you'll receive your response to your LOI by Friday, February 17th. So again, note that the LOI evaluation does not involve an assessment of scientific merit. It will be reviewed by the program managers. Other general guidance includes you can direct administrative questions about the NOFO to Diane Brown. If you ask us administrative questions, we'll forward the question to Diane Brown. You may request high performance computing support. If this is of interest, please email Dan Barry specifically with any questions. And we want to emphasize that public access to grant contract produced data is required as a result of federal regulations. And so the NOFO details on what should be included in your data sharing and information plan. Please take a look at that. A few frequently asked questions. How do I submit my LOI? Please email it to both myself and Dan. What are the proposal page limits? These are detailed in the NOFO, so there's an overall page limit and there's a page limit for some sections. Can I include research funded by other agencies and the results from prior research? Yes, please do include results from prior research that are relevant to your application. How does a multi-institution proposal represent the budget in their proposal? This is outlined in the NOFO. I'm happy to walk you through it. Should my figures be embedded in the text or be at the end of my proposal? Either is allowed, but this goes into the page limit and includes references, figures, and other visual materials for the statement of work or the project summary. There are examples of what should go into your diversity and inclusion statement in the notice of funding opportunity. And we talked about whether an applicant can request federal salaries in the budget. In most cases, that is no. However, there are some agency exceptions. So I went through those very quickly, but wanted to get through those. So we had 5 more minutes of questions if there are clarifying questions from the process details section.
We can give it just a moment or two to watch the question box if anyone has questions. We just got one. For the approximate cost of the project, do you want a detailed budget plan or just a total approximated cost?
Typically, we just get an approximated cost, and there is a suggested range in the notice of funding opportunity. And if it's above the suggested range, we usually ask you to reduce your budget to be in line with the suggested range in the notice of funding opportunity.
Thanks. We can give it another moment or so.
Dan, was there anything you wanted to emphasize that I might have glossed over?
Oh, I think that was a great summary, Ginny. Thanks.
We do have one other question. Can you explain which data sets from GFDL are available to us?
Dan, do you want to take that one? Or John is still on?
Yeah. Well, I guess while John puts his camera on, so there's the SPEAR data set, and you should take a look at the SPEAR website. There's a very clear website available from GFDL that shows the data that's available, the data holdings that are available. There is also the CMAP model archive, which contains both ESM4 as well as CM4 outputs, I believe, John, that's correct. I don't know if you want to highlight other data sets that are available to folks.
No, I think that covers it, Dan. Those are the two big ones.
And then also I'll mention the SPEAR contribution to the NMME, the North American Multi-Model Ensemble, which I think is also linked from the SPEAR homepage. There's a variety of SPEAR data sets available.
Great, thank you. Another logistic question, what is the total budget per year and how many proposals are you looking to fund?
That's a good question. I don't know that off the top of my head, and I don't have the NOFO pulled up. The per year funding or total funding should be in the notice of funding opportunity. I think it's around 1.2 million per year. And then it depends on project budgets and how much each project is that we get in terms of how many projects we'll fund.
Yeah, so the text in the NOFO is 2.4 million available to fund new projects total, and that awards will be up to 250K, and we're anticipating funding 4 to 6 projects.
Thank you, Dan.
Great, I think that's all the questions we have.
All right, we encourage everybody to take a look at the NOFO. It is chock full of lots of information, very dense information. We didn't cover it all today, but thank you for joining.
There was one more question just about whether NOAA collaborators are a requirement. So if you can submit a proposal without them, and definitely yes, you can. You don't have to have the NOAA collaborator.
Yep. All right, thanks everyone. We look forward to reading your LOIs.
Thank you.